that coming through okay?
Yep.
Cool. Okay, thanks, Steve, for letting me talk this evening. And yeah, thank you all for listening for 20 minutes. I think on that note, 20 minutes is not nearly enough time for all of my content. I think, as Steve mentioned, I have a book. And yeah, I literally have a book worth of content that I could be talking about. So I've picked a few topics that I think are relevant for this topic, which I'm going to try and speed run through and try and get to the end of the deck. So if you have any questions, just post them in the chat, and hopefully we'll have some time at the end to go through them. If not, then just add me on LinkedIn. More than happy to answer questions there as well. Okay. So who are we? Very short. The main takeaway here. So I'm Thomas Smart. I've had over a decade of experience with Amazon, and I think importantly on this topic, since 2016, I've mostly been working on serverless projects. It's around after Lambda and API Gateway got launched. And last year, I authored a book about serverless, which a lot of the content in this deck is from. So I think everyone here should know, at least on a high level, what serverless is. So I'm not going to talk too much about that. The three key requirements that I have for considering a service to be serverless is really that the operating system and software are fully managed by the cloud provider. Redundancy, failover, backups, and security is also largely managed and made easier through configuration. But most importantly is that you only pay for actual utilization, that you're never paying for idle time. So that rules out a few of the Amazon services. Today, we're talking about getting stakeholders on board. Stakeholders, in my mind, are those people within an organization that are the decision makers, but they may not be very technical. So our developer, like the application teams, are technical enthusiasm about serverless that might not resonate with them. And so if you want to use serverless for a project and it's the right choice, then you're going to have to talk about the topics that could impact them and how serverless can really help solve their problems and benefits that mean things to them. So we're going to be focusing on things about budget, security, compliance, and people. And I find that these stakeholders will especially want to see some proof that serverless is really the right choice for the project. Make sure that it's not just some buzzword that you want to play around with. So the key challenges of serverless, the first one is really vendor lock-in. And this is because serverless services tend to be proprietary. If you look at the Lambdas, the API gateway, they're developed by Amazon. You configure them on Amazon, and porting that to an Azure or GCP or something, it's not necessarily copy-paste. It can take some work. Now, I find that many organizations just have a single or a primary cloud choice. So this shouldn't really be an issue. Enterprises, however, that have multi-cloud requirements, and especially if that's regulatory, it can be problematic for them to do serverless. For me, latency is really the biggest challenge. Serverless design tends to be with many microservices, many different services. And so you have all these little steps between each of those, adding a tiny bit of latency, and that can really add up over time. But latency is a technical term, right? This doesn't really speak to a stakeholder. So you need to translate that depending on the impact latency could have within your project. For example, if it's a user-facing application, then high latency can be bad for the user experience. So that's something to look out for. And mitigating that tends to be through just architecting the application a bit different, making use of asynchronous requests or parallel requests, minimizing the number of steps that you might have in a user request. Finding talent. Serverless is still quite a rarity in the enterprise space. So vendors that have serverless experience and candidates like staff that have serverless experience, they tend to charge more or have higher salary expectations. And I think for these type of enterprises that probably have good developer resources internally, just taking the approach to train them, let them get experience at serverless is probably the best course of action. And especially DevOps and deployment automation is really important skill to have for serverless. Another key challenge is that with less responsibility, because more of this is given to the cloud provider, also comes less control. So again, if you're in a regulated industry where there may be very specific requirements around security configuration and things like that, it might not work for serverless because you don't have access to many of those underlying security configurations because they're handled by the cloud provider. Service level agreements kind of falls in that same category where if you're promising your users SLAs, then you're not going to be able to offer more than the cloud provider offers you for those services. And certain cutting edge services, they might not even have an SLA yet. So this is something that definitely needs to be considered. Cloud management, I find a big challenge, especially with bigger enterprises. Um, so how your organization manages the cloud is really important here. With serverless, the application code and the application infrastructure are sort of really closely intertwined. Like that, the line between those is really blurred compared to working on servers. And so separate teams for resource provisioning, if that's how your organization is doing cloud management, can make it really challenging to productivity, as you'll be sort of constantly raising provisioning and change requests throughout development. So this can be a big challenge. On the other side, we have the key benefits. So my favorite is near zero wastage. And for me, this is really the biggest benefit. At the top, the graph there, you can see the light gray is utilization of a typical single time zone business application, and the gray area is the wastage. And so this is resource capability that you're paying for but never using. Below, you see the serverless one. So the dark line there is just a margin of wastage that you have, but it's considering less than the server-based one. And this is not just sort of a waste of money, right? I can also consider this to be a waste of electric for those organizations looking to be more green. So that might be something to bring up with stakeholders. Other benefits include sort of the reduced scope of responsibility and effort. So that's again I guess the silver lining of less control also means that the application teams can focus more on application code and configuration and less on sort of the underlying plumbing that doesn't directly result in any return on investment for the stakeholder. Accurate operational and per cost estimation and tracking. We'll talk about this a bit more in a next slide. But with serverless compared to server-based, your cost estimates can be far more fine-grained and accurate, and this can be very useful for the more financial stakeholders. Highly reusable microservices is another benefit. So you can consider something like a thumbnail generation microservice, which is easily reusable across multiple applications. So within an organization, certainly a larger organization, you can build kind of an app store of these microservices that can be reused in future applications. And depending on your security policy, these could even be considered pre-approved patterns or applications so that you can get these much faster through your security approval process for new applications. Better access security. So when you think of a legacy application, you have a single code base. That single code base, the entire code base will have access to a sensitive database, for example, for it to be able to work with that. In a microservice architecture, you can split that down so that only a specific microservice has access to that sensitive database. So you have a much reduced scope, as it were, for each microservice. So if you have like a very sensitive database with personal data, the single microservice could act as a gateway, and that is one point of contact where you can do your monitoring, your auditing, and making sure that any access to that data is sort of validated. You have significantly lower maintenance cost. So the cost to maintain all the underlying infrastructure and everything that's powering these services, that now sits with the cloud provider. So that's included into the service cost. And the cloud provider will get sort of economies of scale that most organizations will be unable to achieve. So that definitely brings down your overall maintenance cost. I find it also much easier to manage time, budgets, and teams. So again, with serverless, you're usually working with microservices, and microservices are very defined and very small in scope, and it translates really nicely between user stories and microservices. And so it becomes, if you have a project manager, they do need to be more comfortable managing multiple small projects in parallel compared to one big project. But this can be a great benefit again. So the type of projects that serverless can work for is quite varied, and the more experienced the team becomes with serverless, the more projects are suitable. But it's definitely not the end all. I mean, there are certainly projects and scenarios where serverless just isn't appropriate. I find that for prototyping, MVP is a really good use case. If you're just quickly testing concepts in all kinds of different areas, serverless works really well for that. For startups, serverless is often just worth it for the cost benefit and the low infrastructure investment alone. We'll talk a bit more about that in the next slide. Digital transformation. So after a lift and shift, you can consider moving the features of the legacy application into individual microservices. The advantage of this is that you don't need one big transformation budget. You can do this in a series of mini projects. You know, get approval for a little bit of budget, move that into a microservice, prove that that was added value, move on to the next one. So it's easier to sell these sort of bite-sized improvements internally than bigger, complicated projects. Pipelines is a perfect use case for serverless, especially if they're sort of event driven. At Source, we actually use serverless in our deployment pipelines and security controls, things like that. Netflix uses a serverless for a media management pipeline, which I think is a great use case as well. Small sites and small forms, things like that, are really good use cases. It'll really cost cents or even nothing to host these kind of pages. Your biggest cost is going to be data transfer. So again, good use case. Now, large applications is where it gets a bit more complicated because there's so much going on in big complex web applications that there isn't really, you can't really say that serverless is or isn't the right choice. You really need to break the application down into different sections and determine for each of those what the best architecture is. So very, very common for these kind of solutions to end up being hybrid, where you have a mix of serverless and server based. I mean, I always say, I mean, you just have to pick the best tool for the job. And for large applications, that can be multiple tools. Areas where it's maybe less appropriate is sort of, I just mentioned a bit about that traditional IT management approach to cloud. It's not good for serverless. Like that can work for server based in the cloud, but it just really doesn't work for serverless. It's really bad for productivity. And so you could have teams experimenting a bit with serverless to see if there's something there, if it's appropriate. But generally, my advice would be to first work on improving how the cloud is managed before getting to serverless. And again, so low latency can be problematic if you have an application that needs really, really low latency, especially if it's more complex with many different services and many different steps and requests. It can be challenging to meet low latency targets. And last one, also mentioned multi-cloud. I mean, if there is a requirement within the organization that an application has to run on multiple clouds, then Kubernetes is probably going to be a better choice than true serverless. So estimating operational cloud costs is something that is a little bit different with serverless. So if you're doing server-based, then the estimates are going to be based on sort of the quantity and the type of servers. That's probably going to be your biggest cost factor. And if you want to get per user costs, it's actually kind of hard to do, and it's very, very much an approximation on server base. You look at how many users a server can support, more or less, divide it, and then you end up with a rough per user cost. Also, the cost per user metric over time is I find a very interesting comparison to serverless. So with server base, you have this high upfront investment where you have to procure or provision these servers that are very underutilized at the beginning. And then as your user base grows and you get more and more users, that cost per user sort of drops over time. With serverless, the estimates are really going to be based on actual requests, actual utilization metrics, so requests, execution time, storage. And because of that, it's going to be far more accurate, but you have a lot more parameters that you need to consider in these estimates. So these estimates, these spreadsheets tend to become these very big, complex things to get sort of accurate pricing, but it is very accurate if you have the right parameters. And that same approach can be applied to get a per user costing. So you can look at what you think the activity is going to be per user, and so come up with a very accurate per user average cost. If we look at the graph on the right for cost per user over time for serverless, you can see it's actually very, very linear. And that's because you're paying for utilization. So when you first start out with 10 users, you're paying for 10 users. When the user base grows to 100K, you're paying for 100K. And this is really one of the reasons why it's so attractive for innovation projects and for startups as well. tracking operational cloud costs, like similar to doing the estimates with serverless, you can very, very accurately track users through an application. So they arrive at the first one, you can time how much time they spend there, the number of requests, how much data they're storing. All of these things are very easily trackable, and you can end up with a table like this at the end of the month where you can see, okay, each user has done this much activity, and that has cost us this amount. And so this enables sort of the cost-based billing to either users or cross-departmental billing. That is very interesting for new business models. Shared responsibility is applicable to all cloud providers, and I think it's really important, at least for me, that the stakeholders really understand this concept and know who is responsible for what with each type of architecture. And this applies to maintenance, to security, to all kinds of aspects for the application. On a very high level, basically, the more abstracted a cloud service is, the more responsibility is with the cloud provider. And so if we look at the top one here, infrastructure as a service, there's many colored blocks there. There's a lot of responsibility on you to manage this kind of infrastructure. And especially sort of the operating system and the software is where you're doing your security patches. You have to keep it up to date. A lot of time goes into that in terms of maintenance. Then one step higher is when we're looking at sort of containers or Beanstalk, where the operating system and the platform is then with the cloud provider, and you're still updating and patching software, but other than that, it's just configuration and code. And at the bottom, we see sort of the highest current level available, which is really the function as a service, where you're really only responsible for the code and the configuration, which includes the access, but everything else is responsibility of the cloud provider, and they're maintaining that, they're managing that, they're updating that. Privacy is another big topic that stakeholders are very likely interested in, especially within global organizations that may have to meet the GDPR standards. Serverless, again, has some benefits here. So there's the very much tighter permissions on microservices that I mentioned earlier. So you can have this kind of concept of a gateway microservice that has exclusive access to a sensitive database, and all the requests have to pass through that, giving you one place to monitor the use of that data and make sure it's authorized. There's the fact that pretty much all serverless services have encryption enabled, mostly by default, and really with no overheads or any additional costs. So there's really no reason not to encrypt everything. And then you have some really great dedicated services such as Macy, which can detect sensitive data in an S3 bucket, and it can scan sort of new incoming data as well. And services like Cognito, which is fully managed user authentication. But this could also be a safe place to store personal data, which keeps it all in one place, easier to manage and audit. Last slide. This talks a bit about the roles. I mean, with every technology evolution, you have an evolution in roles and responsibilities. And with serverless, I don't think there's really new rules, but there's more of a focusing of a specialization of existing ones. So for the cloud architects or the software architects, the focus shifts from, I guess, sort of networking and servers and operating systems to just being familiar with the hundreds of distinct services in the cloud. So, I mean, keep in mind, we want to use fully managed services and avoid reinventing the wheel for any of this, and avoid self-managing things where possible. Also need to be familiar with really the configuration options of many of these services and how they interact and integrate with each other. DevOps and sort of deployment automation become a crucial skill really for all members of the team. They need to be at least comfortable using deployment pipelines and tools to get the most out of serverless. And it can help having a DevOps specialist at the start to sort of set things up correctly. But yeah, everyone needs to be familiar with this. Developers, they will probably get more focused on programming languages that are more optimal for microservices, such as Node.js, Python, and also get more used to working with microservices and not larger chunks of code. In the cloud, we're also not really using SQL for everything anymore. We have the concept of purpose-built databases, and actually quite a few of those databases on Amazon are serverless, which is great. So understanding each one of those types, what they do, what type of data they're most suitable for, will just really help the team get the most out of a serverless project. I've mentioned security, I think, several times through the past few slides, and it does seem like security is changing a little bit in terms of, I think in more traditional security you had more sweeping security policies that could apply to like a whole application or even a whole organization. I think that's changing a bit. I think it's becoming far more fine grained. And it can even be things like time or location bound, which means that I think there's a lot more hands-on security work in serverless projects if you really want to go as far as you can with security. So having someone in the team that just really understands the security capabilities and constraints of each service and just really can make regular adjustments to the security policies and permissions of microservices and users can really sort of increase the overall security of a serverless solution. And I think last but not least, project managers, they really need to be agile. They need to be comfortable managing multiple smaller projects in parallel across multiple resources, sometimes even across external resources, because it becomes much easier to involve freelancers and vendors in these type of projects. That's it. I'm kind of out of breath. Let me see if there's any. Where can I see the chats? I think I have to stop sharing.
I think Atom raised his hand.
Yep. Who has questions? Let me know.
Hello.
Hi, Artem.
I have a question regarding one of the slides. You have mentioned that it's well suitable for the MVP and prototyping, but from my understanding, usually microservice architecture is far more complex compared to the monolith architecture. So I wanted to check, maybe I'm missing something, or maybe by MVP you mean something really small, which is just one routine plus maybe connection to some simple database.
I think this comes down to experience a bit as well. I mean, if you have a team that is used to doing monoliths and single code base, and you ask them, okay, now you're going to start doing MVPs on serverless, it's not going to go down well. I think this is an evolution to get more familiar with serverless. And if you start looking at the benefits of reusable microservices, so that app store concept that I mentioned before, if you then start thinking in terms of MVP, okay, we need to do an MVP that is going to be like, it's going to consist of X steps. Now, 5 of those steps we already have in our app store. So we just grab them from there. That's half the project, half the MVP done, proven, tested already. And we need to add on those steps that we don't yet have. So I think that's over time is where you really start to see you can speed these kind of things up much faster.
Okay, thank you. And I have another question regarding the preferable architecture. So it's usually something is a mesh based. So every microservice connects to some another microservice, or that is usually message queue based. So there is some pipeline and microservices connecting there. What's your preferable choice in like general projects?
I mean, I think that's what I like about microservices is that they're so versatile. So my answer would be yes. Is really whatever is necessary. I mean, if you're working with an API gateway, then you want a Lambda microservice that is just going to reply as quickly as possible to that API gateway and not keep users waiting. If you have something that gets triggered by an uploaded file or an S3 bucket, then you have an event-driven microservice. Wherever possible, I do try to decouple. I try to use events. So a common pattern that I fall back on is I might have an API gateway that with a Lambda behind it that accepts an incoming request. It just sanity checks that a bit for whatever sanity check, and that can't be done on API gateway. And then it returns essentially a response saying, okay, we've received that request. We're going to go ahead and do something with that. But that feeds back to the front end to say just that it's been received. And then that would trigger off maybe a step functions or an SQS or some kind of asynchronous backend backend process that can then go and do whatever that job is and not keep the user waiting. And when it's done, then we can go back through WebSockets or some other notification to let the client know that it's been handled. But this is very much dependent on the application, what you're trying to achieve, and if that's suitable or not.
Okay, thank you. And one small question. You mentioned that security gateway or proxy, which I guess acts as a reverse proxy. And from my point of view, that might give us some penalty on like productivity. I mean, if you are connecting to the database through some reverse proxies, that might inhibit speed.
Yeah, so that's really where that latency challenge comes, right? So at a minimal, you're going to probably have an API gateway, which is your API front, which is a fully managed service. You might have a web application firewall attached to that. You might have Cognito authentication also attached to that before it gets to the microservice. Then you have the microservice itself, which might then be talking to a database or an S3 storage. So all these little steps, they all add latency. Now, each one is going to be fairly low, but this can add up. And this is why it's just really important to have as efficient as possible code and to really think about the architecture and how quickly you can get a response back to a user. And that's why I say as well, if you have an application that is super latency sensitive and you need to talk to multiple databases and get that response back to the user, then serverless probably isn't the right choice.
Okay, thank you very much.
Thanks.
Okay, there are other questions in the chat.
Share about the book. Yeah, so the book is more for non-developers. The book is 3 parts. The first part is very non-technical, so that actually reflects very much what I've just been talking about. So it focuses on the strategic aspects, the impact, and what the non-technical people, I guess, really looking for in serverless. Then there's a sort of a similar size chunk that gets slightly more technical. It's more aimed at project managers and technical leads. So it gives them the information that they would need to get started with serverless, get a team started with serverless. And then at the back of the book, there are some use cases and even a little bit of code sort of to help that technical team get started. But my first target for this is definitely the lesser technical members of a project team. That was from Chris. Thanks, Chris, for the question. Unit testing or local test? That is a massive topic. I think I have a whole chapter about this in the book. This often actually comes up. So local development of services that are very cloud native, and this can be done. I mean, if you look at SAM, for example, so AWS makes a tool available called SAM. With this, you can do local development testing and unit testing of Lambda functions, and it can even mock things like DynamoDB and step functions and other kind of events coming in. So there's definitely resources out there to enable you to do local testing and local development. Thank you, Sriram. I hope I pronounced that right. From Bernard, how successful have I been in convincing non-technical users? Well, how many people here are sold? I think I've done quite well. I mean, since 2016, I've mostly been doing serverless projects. That I have turned down projects because serverless just wasn't appropriate for it. But on the whole, my suggestions to use serverless and how I've delivered that using language that appeals to stakeholders, I think has worked quite well. I've done entire data ingestion pipelines in maritime industry that is not really known for their high tech. So I think it's gone down quite well. And then from Sriram again, other question, tips and tricks. Solve the challenge of a cold start. Well, you mentioned Java-based Lambda. So if you're doing Java in Lambda, latency is not going to be one of your goals. You're really going to have to use Node.js or Python to get fast Lambdas. Cold starts can be difficult. I mean, every time you launch a Lambda, it's going to remain active for about 30 minutes unless you update it. So if you don't have enough users to keep that warm, you could use something like CloudWatch Synthetics to just trigger that Lambda every 30 minutes and keep it warm. But that'll obviously have a cost attached to it. Oh, now there's lots of questions. Give me a minute to catch up. How to highlight the risks associated using serverless to the stakeholders from Nirav. I think it's kind of the same as you would do that for any project, really. I mean, every project, every type of architecture has risks, and you want to find and mitigate those risks as good as you can. And the same applies to serverless. Serverless will solve some of the risks that you would have, and it will create new risks. I've covered a few of those on the slide. My book has more. But yeah, just talking about the risks that apply to your project and what you're trying to achieve, and then really just looking at how can you mitigate that as good as possible, and just being open and transparent about that. I mean, you don't want these things to pop up halfway through a project. So it's I think it's, for me, it's always important to do the research up front, make sure serverless is the right choice. And from Artem, latency adds up between microservices. Average, that's rough. Yeah, so you have local network, you have if it's a cold start or a warm start, so if the Lambda was there or if it's just freshly been launched, if it's in a VPC or not, what kind of libraries and stuff. I mean, there's many aspects in there. I mean, the same applies to booting a server. That can take anywhere from 1 to 5 minutes, depending on everything that's going on in that server. Generally, I would say up to a couple hundred milliseconds, but yeah, it really depends. I've seen with step functions, it's fairly consistently 100 milliseconds between steps. I'm not quite sure why that is the case. It's something I've been meaning to ask Amazon. Thanks, Artem. And Chongwei, serverless architecture for NLP. Yeah, that's a tricky one. So when you get into machine learning, especially if you're doing training, serverless might not be the best option. That being said, Lambdas do now go up to 10 gigabyte of RAM, so that is useful for some ML. But generally, I would just stick to SageMaker for that. I mean, SageMaker is a fully managed service, so it's not serverless, but it's fully managed, and there's really good controls in place to schedule when these things run, to shut them down when there's idle time, things like that. So you have a lot of control over these instances. So I would definitely look at SageMaker.